Dear students, I am Vijay. In this video, let us learn reduction formula for integration of cos to the power of n x into dx. Reduction formula for integration of cos to the power nx into dx. To evaluate this, let us consider this whole term is equal to in. Let in is equal to integration of cos to the power nx into dx. Here n is there, where n is a positive integer. This n can also be write it as n minus 1 plus 1 is equal to n. Here plus 1 and minus 1 gets cancelled, and again we will get n only. We write this equation as in is equal to integration of cos to the power n minus 1 into x into cos x. This here plus 1 and here n minus 1 cancel, again we will get integration of cos to the power nx into dx. Now we have to integrate this by using integration by parts. Integration by parts, choose one term as u and another term as v dash or dv. Here I taken u is equal to cos to the power nx into dx and v dash is equal to cos x. Integration by parts, integration of u into v dash is equal to uv minus integration of u dash into v. Here u is there and v dash. Here u dash represents the differentiation of u. Differentiation of cos to the power n minus 1 into x is n minus 1 into cos to the power n minus 1 minus 2, that is n minus 1 minus 1, that is n minus 2 into x into cos x. Differentiation is minus sin x. Here u dash represents differentiation of u. Here v dash is equal to cos x. Integration of v dash is, as you all know, that integration of cos is sin x. Now come to this here, come to this point. Here u integration of u into v dash is equal to, here first is u is cos to the power n minus 1 into x into v is sin x, isn't it? Minus integration u dash is this one, n minus 1 into cos to the power n minus 2 into x minus sin x, this one u dash into v. Here v is sin x. Okay, in the next step, here this one as it is. Here minus is there, here minus is there, and here minus is there. Minus into minus plus. Here n minus 1 is constant, take it outside from the integration symbol. Remaining is cos to the power n minus 2 into x. Here sin x into sin x. Sin x into sin x is sin square x. Okay. In the next step, as it is, only this term. Here sin square x is there. We can write sin square x as 1 minus cos square x. Okay. In the next step, here multiply this one, n minus 1 throughout this one. We get n minus 1 into integration of cos to the power n minus 2 into x minus, here minus is there, minus into plus is minus n minus 1 into cos to the power n minus 2 into x into cos square x. Bases same means index must be added. Cos to the power n minus 2 plus 2 is plus 2 minus 2, plus 2 and minus 2 gets cancelled. Remaining is integration of cos to the power nx into dx. Okay, in all remaining terms are same. Here in the next step, see here in is equal to cos to the power n minus 1 into x into sin x as it is plus n minus 1. See here, we know that here in is equal to integration of cos to the power nx into dx. I1 is integration of cos to the power 1 times of x, 1 x. I2 means integration of cos to the power 2. I3 means integration of cos to the power 3. In minus 2 means integration of cos to the power n minus 2. Therefore, integration of cos to the power n minus 2 into x into dx can be written as in minus 2. Therefore, here this one is in minus 2. Here minus of n minus 1 into integration of cos to the power n x into dx is in. This one is in. In the next step, shift this one minus of n minus 1 into in to the LHS. After shifting, here minus becomes plus n minus 1 into in. This is equal to remaining terms are same. Remaining terms are same. In the next step, take in common. Remaining is 1 plus n minus 1 is equal to here RHS as it is. Here in the next step, plus 1 and minus 1 gets cancelled. Remaining is n into in into is equal to RHS value same, cos to the power n minus 1 into this one same. In the next step, divide throughout this equation by 1 by n or transfer or transpose n to the RHS. Both are same. Dividing throughout this equation by 1 by n means in is equal to integration of cos to the power in x into dx. In means here this is our given function, isn't it? Given integration. Integration of cos to the power n into x into dx. This is equal to cos to the power n minus 1 into x into sin x divided by n plus here n minus 1 divided by n into in minus 2. This is the reduction formula for integration of cos to the power nx into dx. Evaluate integral 0 to pi by 2 cos to the power n x into dx. To evaluate this one, let us consider the whole integral as in. In is equal to 0 to pi by 2 cos to the power nx into dx. But we already know that we already derived integration of cos to the power of nx dx is this one. Just applying the limits 0 to pi by 2. Okay. Here this is the first term and this one is the second term. This is the constant term. We cannot apply lower limits and upper limits to this one, but because this term not containing x, okay, only apply upper and lower limits to this one. This second term as it is, same n minus 1 divided by n into in minus 2. Here applying upper and lower limits to this one, here applying upper limit cos pi by 2. As you all know that the value of cos pi by 2 is 0, isn't it? 0 into this one is 0. Cos pi by 2, its value is 0. 0 to the power of n minus 1 is 0. 0 into any number is 0. Applying upper limit 0 minus of applying lower limit. In the lower limit, for applying lower limit, here sin 0 is there. Sin 0, its value is 0. 0 into this one is 0. Entire term this becomes 0. Remaining we left with only this one, n minus 1 divided by n into in minus 2. Okay, in is equal to this one. Here this is in when in minus 2 is known. Here if you want to find out the value of in minus 2, just put n is equal to n minus 2 here. Then you will get in minus 2. Here putting n is equal to n minus 2 here. It becomes n minus 2 minus 1 means n minus 3 divided by n minus 2 into in minus 4. Dear students, in the last my video, I mentioned for sine 0 to pi by 2 cos to the power of sine to the power of nx into dx. I mentioned here in the denominator n minus 1. Actually, it is n minus 2. Make it correct. In that derivation, in that evaluation of 0 to pi by 2 sine to the power of nx into dx, I mentioned here n minus 3 divided by n minus 1. Actually, it is n minus 3 divided by n minus 2, because putting n is equal to n minus 2 here, this one is n minus 2 minus 1 is n minus 3, in the denominator n minus 2, okay, into in minus 4. Here to find the value of in minus 4, again substitute put n is equal to n minus 4 in this one. Putting n is equal to n minus 4 means n minus 4 minus 1 is n minus 5 divided by n minus 4 into in minus 2. That means in minus 6. Again putting n is equal to n minus 6, you will get in 6. Continuing like this, here this one ends up with two values, i3 and i2. I3 when n is odd, and I2 when n is even, because this n is a positive integer. This positive integer contains positive even numbers and positive odd numbers. Here this ends up with two values, I3 or I2. I3 here this one ends up with I3 when n is odd number. It ends up with I2 when n is even number. Okay, combining all these values here in this one. Okay, before to that, let us calculate I1 and I0 values. I0 means I0. Putting n is equal to 0 here. Putting n is equal to 0, we get I0, see here, I0, this is equal to 0 to pi by 2 cos to the power 0 into x. Cos to the power here 0 into x, that means cos to the power of 0 into x is 1 into dx. 0 to pi by 2, 1 into dx is x. Applying upper and lower limits, you will get pi by 2 minus 0. This is equal to pi by 2. I0 value is pi by 2. Next, I1. I1 means put n is equal to 1 here. Then you will get 0 to pi by 2 cos x. Cos to the power of 1x means cos x. Cos x integration is sin x. Applying upper and lower limits, you will get sin pi by 2 minus sin 0. Sin pi by 2 value is 1. 1 minus 0 is 1. Okay. When n is even, sorry, here I1 is 1 and I0 is pi by 2. Combining all these values, see here, in is equal to n minus 1 divided by n. Put n is equal to n minus, put in minus 2 is equal to this value here. Then you get in minus 4 here. In minus 4, if you want in minus 4 means substitute this value here. Next, in minus 6, again next term is containing in minus 8 and so on, continuing like this. In the last you will get this one. It ends up with 2 by 3 into I1 when n is odd number, and 1 by 2 into I0 when n is even number. In the next step, put I1 value 1 and I0 value pi by 2. See here, putting I1 is equal to 1 and I0 is equal to pi by 2. When n is odd number, this one is 1. In the last, it ends up with 1. If when n is even, here this one is pi by 2. This is the reduction formula for, this is the formula 0 to pi by 2 cos to the power of nx into dx. This is equal to this one. Dear students, in the next class, let us learn reduction formula of cos to the power of nx, integration of tan to the power of nx into dx, and integration of secant to the power of nx into dx, and cosecant to the power of nx into dx. Thank you.